Good afternoon, everyone. And today we are going to start a series of three parts session on security operations center. And the focus of these three different parts in the presentation will be covering a journey of last 2 decades, which we call as starting from security operations center to what we call today as the cyber fusion centers. So the agenda is distributed like this, that we are going to have in the part 1, we are going to cover cybersecurity operations framework and what are the different components of SOC. Then in the part B, which will happen today post afternoon or early evening, and in the part 2, we are going to cover evolution of SOC through generations. What are the different models of security operations which we have seen in last 2 decades? And also we're going to discuss the key objective, approach, and challenges which are with respect to each one of these generations. Eventually, we will finish the last part of the session, which will happen tomorrow morning. And we are going to cover the current generation SOC components. Then we are going to cover how to build that cyber fusion center. In the last few slides of the session number 3, we're going to cover about what is managed security service providers and what are their frameworks. Just bear with me. I don't know why some people are just popping up. Okay. So as we are starting the part 1 right now, we are going to talk about the cybersecurity operations framework, and this may give you some of the references to what we have discussed in our previous session, where we talked about that cybersecurity 2 decades ago used to be called as a CIA triad, where confidentiality, integrity, and availability is what it stands for when it is called as a CIA triad. And that was actually a framework or a fundamental approach for putting the cybersecurity solutions together. In the confidentiality, we used to ensure that all the solutions which ensure the authorized access and that are able to keep the unauthorized users slash unauthorized access for data and services out of my infrastructure access operations, that will actually be the objective of the confidentiality operations. Integrity was primarily targeted at ensuring the sanctity of the data, ensuring that the data, both in rest as well as in motion, will be taken care of, not being mutated or not being changed or modified by anybody, whosoever that particular person or individual host is. And the availability is assurance of the services as well as data availability for the legitimate users. So those were the three focus areas of doing the cybersecurity solutions. When about 2 decades or about 25 years ago, the cybersecurity as a practice started. Now we have evolved as an ecosystem uh, beyond the CIA triad, and our current framework is more complex, and it is actually a composition or amalgamation of various triads. And if you look at this particular architecture of a triangle of 4 different triangles, this basically is called as a cyber resilience engineering framework, or CREF. And CREF was postulated or or contributed to the industry in 2013 by an organization called as MITRE, MITRE. And if you will Google it, you will be able to get to know about this framework and various other contributions this particular organization has been making with respect to cybersecurity and other associated domains. Now, when we talk about the cyber resiliency engineering framework, the typical CIA triad, which is taking care of unauthorized access prevention, ensuring the data integrity for data at rest and in motion, and also ensuring the availability of resources that are servicing the legitimate users, that triad has been composed as one of the triangle in the rightmost side of this larger triangle. So if you see it, it's called as a conventional security function. So under the conventional security function, you will see this entire triad of solutions have been covered. But when we started evolving these infrastructures as the ecosystem of the consumers of data and information, or the organizations that are hosting the data and information about the users and the business needs, they started to feel that there is definitely a need of continuity of operations. What if something happens to the available data center or the computer which is servicing the customers and that goes down? If that goes down, that needs to be immediately available in the event of some failure. And then started to build the expectation that if suppose we have a data center that is deployed at one part of the world, then the disaster recovery center, which is going to be servicing the customers and the organization in the time of unavailability of the primary resources or the primary data center, that same data center, if geographically is placed close to the primary data center, then the natural disasters can harm both of them together, which means my disaster plan can go for a toss if they both, the primary data center or primary resource center and the secondary resource centers, are geographically very close to each other. Because we have the seismic zones, we have the floods, we have other natural disasters that can impact a single geographical location equally. So therefore, the continuity of operations had to plan a disaster recovery center which is geographically far away, at least in a different seismic zone, at least in a different environmental zone. So this is how, if you see on the left side of this larger triangle, the left side triangle, small triangle, is capturing the details of continuity of operations, not just the continuity of availability of data and service. Because data and service, when delivered from the same compute or hardware or applications framework, if that framework itself dies for some reason, the building collapse or building is fully inundated with the water because there was a flood, then something else has to service. So that's what is the second part of the triangle on the left side of the screen. Then there is a top triangle, that despite having put up all the security controls that are sufficing the need of CIA triad, as well as it is sufficing the need of continuity operations, there is definitely a situation where a resilience might be required, which means the attack will penetrate. And there is no better example to see that today, when we are all being working from home because of an epidemic called COVID-19. And in the context of COVID-19, we all know that today every country is getting into a resilience mode, that how resilient they are, because they know that no matter whatever preparation they would do, this virus will hit them. This impact is not going to be absolutely eliminated to a country. So in such scenario, how will you withstand? and how will you recover, or how will you adapt to the moving issue, is what all is now defined in the cyber resiliency model. So with the COVID-19, taking the cues from a very easily available example today of COVID-19, the similar situation is there in the current generation network and network delivery infrastructures. So organizations today not only restrict themselves to an understanding that, yeah, they have done a great job of having deployed those security controls, and also ensured that they have built their data centers and the disaster recovery operations. They cannot just live with that. They have to plan that should there be an event of an epidemic, should there be an unsolicited, unknown target entering into their environment, how they are going to build the resiliency against that, and also how they are going to anticipate such things. Taking the same COVID-19 example, if we read the ex-WHO, who also happened to be a ex-Norway president, if you read her article in 2019 October, published in one of the magazines, it was clearly mentioned that there is going to be some kind of a pandemic which will impact the world very soon. So there are people, there are systems similar to such people who will be able to anticipate such things from about to coming to your infrastructure. So therefore, the withstand, recovery, and adaptations models are also getting substantiated with the anticipation-based predictive models of predicting a possible cyber threat that can actually scavenge us. All this put together, we are now moving beyond conventional security controls, beyond the cybersecurity operations, and just moving towards the cyber resiliency. And this all is not just restricted today to my organization, but I have to see as a whole in the ecosystem. So it is also very, very important that the detection and response mechanism is for the cyberspace and not just for my organization alone. So whatever conventional cybersecurity, which I used to be only considering about me as an organization, is no more sufficient if the ecosystem in which we are going to exist or we are going to be part of as an organization does not follow that standards. So therefore, you are seeing this central triangle, which brings that capability in the cyberspace and in the ecosystem, what was existent in my organization. So all the black colored text belongs to the ecosystem requirements. And that is like, if in the current IT environment, what we have to consider is that I might have a great security controls in my own organization. But today, if I see as my organization, I am dependent on a mail to some third party called X, Y, or Z. We all know that today the mails are being outsourced or are being moved to the SaaS-based cloud models. Same way, maybe the sales management systems. All such requirements, when we move from our own data center to be serviced and delivered from third party, like software as a service or platform as a service or infrastructure itself as a service, then I am dependent upon their upkeeping capabilities and capacities of cybersecurity. So that's what a middle triangle talks about. So all this is what is a need which the Mitre organizations proposes, that every organization, when they plan their framework for cybersecurity, they have to refer to such framework and not just the CIA triad. Yes, CIA triad was good from 1995 onwards up to almost 210. It had done a great job for 15 years. And nowhere we are saying that that is no more required. It is required, but it has become small subset of my larger strategy, which was the need of the hour in 2010 onwards, when we started to see the complex attacks. when we started to see that, yes, there is one Stuxnet which will start and it can actually blow off the entire Iranian nuclear power plant centrifugation engines by a threat called Stuxnet. And I believe that in my previous sessions, I have given you to read about that. So that happened in 2010, and that's where the entire world started to look at the cybersecurity in a different perspective. So I solicit you guys to read about this in your personal leisure time, because this entire 65-page document, which is available in a public domain by mitre.org on a cyber resiliency engineering framework, explains each one of these elements in a much more minute and the granular details. Moving from here now, this is the diagram we have been referring in our sessions. We saw that in the previous session also. So now let me actually again explain you a bit of this diagram. This handmade diagram basically represents a current generation or a current day's bank. Now let's start with, as a consumer or a user of a bank, we never go to a data center or to a head office of a bank on every now and then. We generally go to some of those elements and at max to a branch office. So let's start from there, what a branch office is. Now, if you look in the bottom of this sheet, there is a branch office which has been shown. It has an ATM machine, it has a teller machine, some desktops, some manager's laptop, and some kiosks where you can interact about the different services and the portfolio which a bank offers. They all are connected on a layer 2 switch and through a MPLS modem. This branch is hooked up or uplinked to a MPLS cloud of a bank. Similar way, other branch offices and some other ancillary business like loan branch or insurance or bank's own call center, they all get uplinked from their respective office/location to this common MPLS cloud which the bank has put up. Now, when we come and get this MPLS cloud dropped inside the main data center of a bank, not every user or consumer of this bank will go and sit into this infrastructure. Only the people who are responsible for delivering the entire banking services up to the leaf object, that happens to be in this case the branch, or any laptop or internet users which are going to come into the infrastructure through internet for internet banking. So both internet and MPLS cloud, if you see now in the middle of the screen while looking at the right side, they, through their respective modems or through their respective physical connects, are getting dropped onto the cluster of routers. Those circles shown in double arrows right in the middle of the screen. Those routers are bringing in or terminating the internet for bringing in internet users or subscribers and connecting all the branch/third party offices over the MPLS. All of them now are terminated on this router. Also on the router, because we all know that these banks are part of a federal banking system. So always in every country, there will always be a federal or a central bank. In India, we have something called as the Reserve Bank of India. So that's our federal/central bank. So that central bank not only ensures the compliance of the bank to the desired banking norms so that every citizen money is secured and safe, but also the central bank does is that it facilitates the interbanking transactions, which means the recipient and the the beneficiary and the person who is actually paid, both are probably from two different banks. So in such case, the central bank does the interbanking operations also. For that reason, this data center of the bank also has to get connected to the reserve bank or the central bank of the country. And that's for we have shown a one radio frequency link, because the main branch of RBI and my data center probably of this bank is in the same city, and I might as well have a RF link than just having an internet or MPLS. Then on the left side of the screen, if you see, that's all banking infrastructure. The infrastructure has some critical servers connected on 100 gig fiber. Then there are some public facing servers like www or mail or DNS. They are on, let's say, 40 gig fibers. Then there are some policy servers for security and network requirement, like network management server, NMS, antivirus server for having the policy or antivirus updates for all the branch level teller machines, and the branch managers laptops and other machines which need the antivirus, etc. All those server side or the policy servers for such requirements have been put up in the network and security management zone, shown in the pink color on the left side of the screen. Then on the orange colors, you are seeing the operators that are basically monitoring the operations of IT, compute, hardware, applications, routing, switching devices, security devices, all that. That's called as a NOC, that is Network Operations Center / SOC, that is Security Operations Center. So all that hosts or consoles who are the monitoring people, they are sitting on a level 2 switch, which is further uplinked to the same L3 cluster on which the other infrastructures are coming. Now, apart from running the bank's own IT infrastructure, bank also hosts the consumer data, the very, very important data. And that for data, the bank has put up absolutely a separate, some banks have put in a separate floor, or they have actually dedicated separate servers in which they have put in the rack mounted servers shown in the middle on the top. If you see, where you are seeing in the orange color written text, core banking servers, internet banking servers, mobile banking servers, loans and treasury, payment gateway. So all that what is required to run the business of the customers of the bank is what you are seeing are part of that particular infrastructure. However, on the left side, you are seeing those servers which are required to run bank's own infrastructure, while in the middle on the top, we have shown you that rack of servers or racks of servers that are basically delivering the services to the customers of the bank. All those have been hosted on some 4 into 40 gig links, which is actually in an aggregate translates to 160 gig pipe from this VMware stack of servers, bringing it to some internal firewall. And that internal firewall is ensuring the security of these very, very, very critical banking systems from remaining banks' infrastructure. Now, all the L3 infrastructure, MPLS infrastructure, internet infrastructure, and this core banking / internet banking infrastructure of the bank, after being serviced through the internal firewall alone, that part of the infrastructure, they all come to now a public facing security gateway that is shown right little left of the middle screen, right in the center of the infrastructure, which is called the Next Generation Threat Prevention, NGTP. The block diagram shown in the pink color of text. Now this gets connected to those routers which are bringing this infrastructure and interfacing it to the external world of MPLS, internet and all that. Now all this is like a real bank. Then we have some bank salespeople or the bank's organizational users who are representing very senior positions. They might also want to connect to any one of these important critical applications, etc., from outside, like the extended LAN users. And we have discussed in the previous sessions that the extended LAN users are also called as the VPN users. So right on the top extreme, just where the purple Synapse logo is, if you can see that we have shown two gadgets. One is a laptop and another is a mobile user. And those users connect to the external firewall or external next generation threat prevention device over a SSL/IPsec VPN to deliver the interconnectivity over a encrypted SSL/encrypted VPN on IPsec technologies. If you look at the internal firewall, which is connecting to the internal side of the very, very critical servers that are hosting banks' own customers' data, they have been additionally protected by an internal firewall internal firewall plus an IPS combo device, an integrated firewall and an IPS device, to ensure that this part of the infrastructure is even protected from the secured infrastructure inside the bank. So nobody can directly access them. So there is an additional layer of security which has come. So there is, if you see, somebody from branch has to go and, because any transaction which you will use at a teller machine in the branch, if you start flowing the application traffic, it will start from that teller machine, come to the level 2 switch. From the level 2 switch, it will come to the MPLS modem. Then from an MPLS modem, it will enter the MPLS cloud. From an MPLS cloud, it will go to the router of the bank, the main router. From the main router of the bank, it will come to the next generation threat prevention device shown in the pink color on the top, somewhere in the middle. Then from that, it will start moving towards the internal firewall. So one level of packet inspection will happen at the NGTP level for both header as well as for the payload inspection. And then the second inspection will happen at the second layer of the firewall and an IPS to ensure that it is double protection. Similarly, if any server which is present in the public facing domain of the bank, when an internet banking user will come via internet, from internet, it will enter the internet modem into the router. It will come to the NGTP switch, NGTP gateway, which is shown again in the pink. And from there, it will go to directly to the switch. And from switch, it will come to the web server, hosted on the left side of the web server when you are seeing on the left side of the switch when you are seeing the screen. In that public facing brown color, text which we have shown, those servers. So on that web server, www, the internet banking is hosted and it will be responded. Imagine that in this transaction, there is only one inspection which is coming, and that's the next generation threat prevention, which is protecting it against the payload attacks as well as against the header attack. But now we know that inside the internet banking, once I start reading if I am an internet banking user, my own account statement, that means this web server will have to make one request to somewhere in the VMware stack on the core banking or our internet banking servers. Because web server will actually be able to see only the bank account if and only if it will come to the internet banking system. So that request will then further be inspected between two layers of security, because that traffic will flow from that server towards that stack of VMware via NGTP, and the internal firewall plus NPS. So all these are the flows of data which move. When these flows are moving, we are seeing there is a router, there is a client machine, there is a web server, there is an internet banking server, there are core banking servers, there is NGTP gateway, and then there is internal firewall plus NIPS. So many infrastructure components are coming into picture. All of these devices are seeing the transactions. And when they are seeing the transactions, they are generating something called as a log. And that log has all the intelligence about this transaction. It will not know what actually you have done inside the internet banking if you have transferred 100 rupees or 200 rupees. But it will tell you that this user from internet has come and transferred the money. So all such transactional log data is of a very, very important requirement to us to understand what is happening in this layer of security and the layer of network. So such logs are now becoming a very, very important piece for us. Looking at this diagram. But if I look at this diagram, it is very easy for us to visualize that any transaction will pass through some network device or some security device from where I can collect the log data for doing these security operations on the top of it. But definitely looking at some parts, when we go as the consultant, we figure out that there are some blind spots. Blind spots are those areas in the network where there is no visibility, where there is no log getting collected. And these blind spots are very, very prevalent in the telecom network. So we have to understand, this is one of the telecoms with which we are working. It's real network where their enterprise, their broadband, their mobility, 3 different businesses, they are going to the service provider network. But most important thing is that unlike the bank environment, not too many security controls are deployed here. Not too many devices will see the transaction. Why? Because it is very, very evident that the kind of volume of traffic which this particular bank will see towards its internet, let me tell you, the maximum network I have seen in a bank till today is 1.2 Gbps of internet pipe and maybe another 1.2 Gbps of MPLS pipe. Add these two. So hardly 2.4 Gbps. So putting devices like NGTP, which you are seeing, or an internal firewall plus NIPS, or putting some kind of security on a router or a layer 3 switch is quite possible because the throughputs are 2.4 gigs. But now let's imagine a telecom provider. Now, when you are watching a movie from Netflix, you download a movie which is as big as 1 GB. So if your service provider is giving you in few seconds to maximum to a minute download of a movie or real-time streaming you are watching for a movie or any real-time show, imagine the kind of bandwidth you getting multiplied by the number of people who are actively interacting or interfacing with the same telecom service provider. Maybe 3 or 4 customers need itself will be as good as the 2.4 Gbps of what a bank at the perimeter or the core, main core will have it. So in the telecoms, let me tell you, it will be the tune of 120 to 220, 240 Gbps per site. So if you see one location like Chennai might need a 240 gigs speed. So if you put this in Delhi, if you put this in Mumbai, put together, maybe a telecom provider will have few of terabytes of traffic coming and bringing into the in and out of the country. So at such layers, it is quite possible that we will not be able to collect the logs from each of the devices, because all such security controls that can be deployed in an enterprise called bank may not be possibly deployed in enterprise called telecom. Therefore, in the security operations center, a very, very important element comes called as a tap. Now, tap is where you will actually break a fiber, put a connector in between, two pipes that is in and out are connected through this tap, and there is a tap which is open now, like a third interface. So this is like a optical coupler which will couple in and out the fiber, which is actually acting as a connector for 120 gigs of traffic or a 240 gigs of traffic examples that I've told you. And then this tap, the third interface on that coupler tap, will go into like a surveillance camera. So you get a full spectrum of the traffic being seen. Now, on a typical surveillance in the cyberspace, that device is called as sentry. Sentry has a dictionary meaning or a dictionary meaning. The one like who is a security guard. So they will watch. So tap and sentry will get fixed on such requirements. Okay. Now, why I am explaining you this is because not that you have to now start working on a telecom infrastructure, but you need to know that the logs get collected from routers, from switches, from servers. We all know that. But there are very, very important elements which are going to cover those blind spots from where we'll not be able to see the logs, and that are getting covered by a tap and a sentry. Okay. So these are two separate components. Tap is just like an optical coupler or a copper coupler, which will have in, out, and a third, which is called as a mirror or a copy. And then on that, you will put some intelligent layer 4 to layer 7 device, which will be able to understand what is happening at the application layer, which will understand that what are the ports which you are opening on the session layer, what is the protocols that you are using, a UDP, a TCP, or IPsec, or a GRE, or any other on the layer 4. So all that layer 4 to 7 intelligence this device will have to keep an understanding of that. So this is the whole objective of explaining you these two different infrastructures. Now, once we have now all the devices which are going to generate logs or to cover these blind spots by the virtue of tap and sentry, let's move on now. Let's start to build now security operations center. We have all the logs. What will we do with these logs? These logs have all the important elements of the transaction. I have already explained to you in the beginning of this session. So what are we going to do with that? We have to achieve something called as that if there is any attack which is happening, or if there are few starting points of some attack which is going to happen, we need to detect it. So the empirical formula says that understand something, that every detection is a function of time. It will take some time to detect something. It will not happen of its own. So that detection time, the time which the devices logs are generated and the logs are interpreted or the insights are drawn, that is called as a time to detect, shown with a with an attribute shown here. Then once you detect, what will you do? The security operations center has to respond. So response is also a function of time. It is going to take some time. to build a response strategy, to actually execute a response strategy. The SOC expectation brings the non-linearity, and it says that the total summation of the time it takes to detect a threat and a time to respond to a respective threat should always be less than or equal to the time for an attack to thrive in. If this non-linearity is broken, then this non-linear equation stands for that the attack has actually happened in your infrastructure. So every 100 times, we as the security operations center engineers, consultants, or we very nicely referred as blue team people, have to always 100 out of 100 time have to qualify for the success of this equation. One single failure in this will lead to an attack. And that's what is an asymmetric advantage which my hackers or the people who are trying to target my customers will have. Because they only need to break this equation once. And that means they are successful. And for us on the blue team of the site, we need to be always 100% protecting it. That's what defines my success. And that's the asymmetry we are all in. But that's the reality. Now, if we have to do this and deliver that equation for the success, we are dependent on three elements: people, processes, and tools. Any one of these functions don't do their job, or if they miss anything in their job function, we will have a failure. Failure in that non-linear equation. People are required to do what all? Let's read this. They are supposed to monitor on the screens what they are seeing on a 24/7 basis. Then they are required to respond. When they are responding, they are following the guidelines of some people who have set them. Those guidelines are what? Those guidelines are processes, the run books. Like in this COVID-19 time, we've been hearing, if suppose, if WHO said that if your country is in a stage 1, not everybody needs to be tested. Only people who have a background of having come from some other country, which is already into the state of infection, only those need to be tested. But when you are in a stage 2, then anybody who comes from outside India or outside your country has to be quarantined and also to be tested if they show a symptom. But in the stage 3, anybody who is showing any kinds of symptoms that can give a 20% or a 30% or a 50% correlation, you start testing them. So this is what is setting up a process. Somebody sets the process, but the incident response team, which means the people, the task force, which is in the front line, which is in the security operations center, they are supposed to follow those run books. They cannot apply their own methodology. They can only apply their skill, their knowledge, their exposure, their experience. And what is their experience? When the incident has occurred. So in the management of that, in the emergency response of that. That's why in the COVID-19 example, you would have seen that somebody experimenting with the malarial drugs, anti-malarial drugs, onto a COVID-19 case. Simply because it's an emergency. Somebody is not being able to breathe. So needs to be responded, needs to be dealt with. So that's the all kind of job which the frontline people are doing. So that's what is people. Same way in the cyber security operations center, people are doing 24/7 monitoring. They're responding to the incidents. Then once they are in the response of the incidents, they need to execute some strategy. And that's what is called incident management. And also in the absolute emergency situation, they need to proceed with any emergency procedure which they feel can lead to any possibility of success. Like a rescue procedure. Then all these procedures, they become standard operating procedures if the success is attributed to them. So for example, if the success will come more often with some set of drugs in COVID-19 case, that will become slowly and gradually a standard operating procedure, because this is going to stay for long. Similar way, in the incident response, when we see that yes, this response mechanism has worked against the WannaCry or any other ransomware, it becomes a standard operating procedure, which means a learning which has happened by going through that process has led to other people to follow those procedures. So that becomes a standard operating procedure. Then incident response books or run books, which basically will say, okay, if you see something which gives you a resemblance of a phishing action, then do this, which means it's not a standard operating procedure, but it is like a interactive procedure. There is something which you will do, and then the outcome of that will decide whether you need to move to the step B or step C subsequently. So there are choices. So virtually what does mean is that a standard operating procedure, when it gets modified further for the changing problem statements or the dynamic problem statements, to be more precise, it gives birth to a more complex procedure book called as a incident response run books. Also, then there are some changes which are a function or an outcome of any attack which is happening. So if suppose you are seeing some attack coming from a specific domain, you would want that URL filtering should be given a new domain to be blocked. So which means a consequence of an attack or a propagating breach has led to a change in the configuration on some particular device. Also, by then doing so, we realize that yes, the best practices was not followed, or a best practices workflow has to be followed, vice versa. Which means anybody who is seeing an attack should always have another person who should authorize a change in the security device. If both are same human being, then there is a likelihood that there is a bias of an individual which come into the picture. He might or she might feel that there is an attack which is happening while it's not true. So that in the change process systems is called as a checker and a maker relationship, which means the person who is making or suggesting a change is not the one who is going to check the change. So you will bring a division of labor or two roles, who creates and who approves. So all these constitutes in the security operations is into a run book called as processes. Sometimes people are doing a great job, but a process fails. We all know that, in the people who have an experience of having done that. They might have done a great job, but they might have ignored, some process, or they did not validate with the knowledge base. And then they went on to make that change. And virtually it has led to an outage. So this happens. So process books are very important. And when we are doing 24/7 TIS operations in our own company, we know that we have set up some process that, okay, if in this time amount, if we are not able to solve the ticket at level 1, it should move to level 2. All these set procedures and processes, they help a smooth functioning when multiple people are involved in this similar set of operations. Then comes an important, very, very important, the tools. The tools, not just the security controls which you have deployed, not just the firewall, not just the next generation firewall with an IPS integrated into it, not just the next generation threat prevention, which is doing both header inspection and the payload security inspection. We need tools beyond those security controls. So those are security controls. Now we need tools which are able to analyze data coming from these security controls, the routing devices, the switches, the servers, the systems, the applications, all are generating the logs. So somebody should be able to collect the log, consolidate the log, draw the meaning by correlation out of the log, and once they see something, they should be able to generate a ticket, should be able to do a change management ticket, because there is a likelihood that an attack might demand a change on a security device to fine tune the configuration. And there is a likelihood that that change might be required permanently or might be required for some small amount of time. Then there have to be a compliance validation. And last but not the least, the AAA, the security authentication. Sorry, security controls, authentication, and administrative management. The AAA solution has to be part of those tools framework. There is a possibility that a company might have already invested into a next generation threat prevention and antivirus solutions. Also, they have invested into, let's say, a VPN solutions for ensuring security of the data in motion when the users are working from home or on their own, bring your own devices. But they might not have invested into AAA. They might not have ensured that the privileged user actions are monitored and are being defined. All these functions of AAA, therefore, are part of the tools of the security operations, because that's how you are going to define the administrative privileges on the security controls. So all these tools, processes, and people, we are going to delve in further, but in the opposite direction now. The importance is, what is people, the most important component, processes the second, and comes the tools when we are setting up a SOC. However, when we are trying to understand the SOC, I'm going to start opposite. So I will start with tools, then we'll understand processes and people. So what is a tool? The most important tool which is required to set up a SOC is called SIEM. It stands for Security Information and Events Manager. I'm going to explain this diagram in a short while. But the most important thing which is written on the top, you guys have to understand that the most customers whom I have visited across the globe and have seen them, had an experience with them, most customers, let me tell you, in my 2 decades of experience, I have seen them having made the wrong assumptions that SIEM is equal to SOC. For them, if they are taking SIEM, means they are taking SOC. This is absolutely incorrect. SIEM is not equal to SOC, as I have written in the blue text on the top. It is not equal to SOC, because I have just shown you in the previous slide that SOC is people, processes, and then comes the tools. You might have an amazing team of people, but you are very weak on processes, then you would need some kind of an SIEM. But the journey which I have seen in 2 decades, which most customers have taken, they've already finalized what SIEM they want to buy. And then they're putting people and processes around it. It doesn't work in this direction, because they believe that, or they have believed that SIEM is equal to SOC. Okay? In a very simple layman language, if you have to explain it to your grandfather or your parents or to grandmother, you just have to simply say that SIEM is a centralized log collector, which is going to do security correlation. We all understand, and read it absolutely like a dictionary, period. Centralized, we know it's some central place. Log collector means somebody is generating some log and it should be able to collect that log at the central place. And what it should do or deliver after collecting the log, it should do security correlation. It should be able to connect the dots and should be getting, after connecting the dot, it should be able to deliver an insight. That's period. So these are 3 important things which I thought needs to be understood from SIEM, which you guys need to understand. Now let's look at this diagram. On the extreme left side, I have just broken down the type of devices which we see most commonly. Router/switch. Inside that triangle, rectangle, you would see that There are two kinds of primarily the logs which we are going to use. One is a syslog. So every router slash switch is going to generate something called as a syslog. So first and the foremost thing which I have to do is, if I have to bring that syslog onto this SIEM by this blue color arrow. At most, in some scenarios, in some advanced scenarios, we all know that, and if you don't know, please find it out from Google, because this is beyond the scope of this session, that every router slash switch is aware about what is the traffic that is flowing, because it's knowing those packets in those flows called as net flow. Like Cisco does it net flow, Juniper does it J flow, and similar different vendors in that space will do it in their own respective flow formats. But net flow and J flow, because these two are very important and a very worldly popular vendors, their flows are understood by most SIEMs. So when I want to transfer a full packet understanding from a router to an SIEM, then I would need a JFlow slash NetFlow. Syslog will be a metadata. It will have only very few data elements of the transaction. Then let's come to the next level, which is VMware or a server. So let's say we have a VMware or a equivalent hypervisor. Great. So whenever you see VMware on my slide, don't assume that I'm a proponent of a VMware as a company, but since they are the first ones who have started the virtualization to become very popular about that, I also don't know whether they were the first ones, so I take back my term. So they're the most popular ones, so that's why you see them there. Like in our country, when we go, we might buy a Kinley water bottle, but there was a time people used to say Bisleri dena, and they used to give a Kinley water bottle, while Bisleri and Kinley are competition to each other. Similar way, VMware is just one of the product which has just become a de facto standard. It's not DGRA. So there are multiple other options, like Microsoft is there, Linux versions are there. So let's coming back to, so what I mean is that it's a server or a virtualized compute. From that, we can take syslog data. We should also take a system data. The system data is like the application logs, the system logs, or the security logs which are collected on those instances of Microsoft machines. Then we know that on most occasions, the servers will have some endpoint security, which stands with ES. So I need an endpoint security logs, or they might have an antivirus. I would need an antivirus logs coming from there. Or if they are a pure hypervisor environment, maybe the hypervisor for east-west traffic understanding, those logs. So that logs will come from the server slash compute. Then you come to see the network security devices in that pink color. So from the network security devices, whether it's a next generation threat prevention or a next generation firewall or an antivirus on the gateway, and we have been discussing that antivirus on the gateway will monitor HTTP, HTTPS flows. It will monitor the mail flows primarily, or the DNS flows. All that logs will either be coming in their native log formats, or for example, some devices like Cisco security devices, they give the similar security logs even on the syslog format. So that's how it is going to come from network devices. Similarly, endpoint security devices, the server or the desktop or the laptop or the mobile, whatever it is, other than mobile, I have taken into consideration as endpoint security. So you will get the endpoint security agent, which is installed on that, a Symantec agent or a McAfee agent or a Trend Micro agent or a Checkpoint Sandblast agent, whatever it is, on the endpoints, whatever, whether it's a server or a client side, you will get to see the logs coming from them. As well as you will bring the registry logs for understanding if they have modified any registry entries in those machines. So that's like a system logs. So we'll get these logs from endpoints. Then apart from that, we know that there are some authentication directory systems like Microsoft AD or LDAP, or they are authentication devices for AAA, PIM-PAM solutions or TACAX solutions. All those authentication transactions, which means whom they are authenticating, what time they have authenticated, till how long the person was authenticated, if the token was given to him for authentication, was the token reused? Is there a possibility that the Kerberos can be compromised. And what is that Kerberos seeing? Are they seeing any reuse of the tokens? All those data will come from AAA or AD or LDAP users. See, guys, you please understand, I might be using some terms which might be hearing for the first time. If that's the case, please record it on your diary, because if I'm not explaining, that means they are out of the scope of this discussion. But for understanding SOC, you might be seeing these terms being used, but they're not very required. So I might be using it in my conversation, like Kerberos I have just used. So some of you might not, or might have heard it for the first time, Kerberos token. So you can do it your own research to understand what it is. Then on the mobile security, the mobiles might connect over Wi-Fi inside my organization, because that's the only way they can connect. And also there will be a composition of their own personalized apps on that mobile device and some of the corporate apps on those devices. So there are very specialized mobile security tools called MDM, Mobile Device Manager, or MAM, Mobile Application Manager. So all those are very specific endpoint security controls which are only relevant to mobile. Plus, most mobiles will only come via Wi-Fi inside my organization when they are part of my infrastructure. So Wi-Fi security system logs and the user activity logs, which the mobile security apps like MDM or MAM might have, we need to bring those logs into SIM. Period. So all these logs, when they travel towards the SIM is a single log consolidator, as I told you, a centralized log collector. What will it do first? Now, if you look at the diversity of the people who are, or the diversity of the infrastructure that is sending the log to this centralized machine called SIM, they are sending in their respective languages. You know, somebody is speaking syslog, another is speaking netflow, the third is speaking its own antivirus log format. All these are different languages, syntaxes. Each one of those respective devices will be using. An antivirus log collector from one vendor to another vendor itself will change its language. So in this language, the first process which a SIM has to do is it has to normalize. It means it needs to draw a metadata or the keywords or the extract the intelligence which is hidden inside those syntaxes. And that process is called as normalization process. So every SIM, first and the foremost thing it has to do is it has to normalize it. Normalize all these events. When it normalizes these events, now whether the event is collected from a router or a firewall, it will show only the source IP address, because the packet has been picked up for this event, which means when the event was recorded either by a router or a firewall, no matter the router was Cisco and the firewall was Checkpoint, irrespective of that, they both have recorded the data differently, but they've seen one common thing, that the event has been coming from, or this particular attack has come from the same source IP address. So with this knowledge of normalized, I will only see source IP is equal to this, whether it comes from the source of the event could be router or a firewall, irrespective. That's what a normalization will render. Now, after this rendering comes the aggregation. We understand that that event might have multiple instances which look similar, which are not giving any additional evidence. So, for example, I have tried to do brute force, or I have tried to just compromise a user. I'm trying to do that on a Windows machine. I will keep trying it. When I'm trying it, my source IP as a hacker will be common. Only thing which is changing is that my attempt. So if somebody sees that there are 5 wrong attempts and then on a 6th attempt I am successful, it is a real dangerous thing. So if somebody shows me in the SIM 5 different events separately and then comes 6th event, which is a success, it means I have to read through 6 lines. But what if somebody just composes it, aggregates it as a single event, that there were 5 failures from same IP address and there is a success? Or at least 5 failures are composite as single event, and then there is a success as a separate event. So therefore, such things are very, very important to reduce the commonality or to do a deduplication. Okay. So that process is aggregation. So it's actually not a deduplication, but the events which have multiple sequences but are same types, they get aggregated as a single event, and their number comes as a heuristics. That okay, this has happened 15 times, and this is the time span in which it has happened. And if I click on that aggregated, I will see all 15 events with the different micro time stamps. But virtually they have happened in the similar window of time, so they will be composed as single events. That's the aggregation. Now comes the most important thing, and that's the correlation. Correlation, initially in the SOC tools or the SIM, has deployed the regular expression. So I've expanded that on the right side of the screen. So let's read a regular expression. So regular expressions are the multiple rules. Rule 1, rule 2, rule 3, and rule n, up to rule n. So this will become actually my correlation rules rule book. And when I'm writing this rule book, each rule can be, it's like a state machine, which will have a start point and an end point. And between start and end, the regular expressions are fitted to see if this has happened. Just now what we have talked as an example right now, let's talk. The moment any user authenticates on Windows AD, for example, if the authentication is failed, that means it's a start of some correlation. It will fire some correlation rule in the background that, okay, one failure happened from this IP address, and this failure should trigger for a transient event. Now in the transient states, I said that please see if the failure happens 5th time also. So that's the first transient event I write. So with the first trigger, a correlation rule was just in the meta state, in the embryonic state, and it start looking at if there is any recursive. In the transient, I will say that if within 2 minutes 5 failures come, then move it to a transient state 2. So what does it mean? If this transient state will fail, which means somebody is actually failing as a real human being, there is a highly likelihood that it will exceed 2 minutes window. And if it will exceed 2 minutes window, it will keep on resetting the transient state 1. But the moment transient state 1 is met for this meta embryonic event, it will move to automatically to look for transient state 2. What is a transient state 2? Wait for another 30 minutes if a success happens now in the next 30 minutes, which means somebody has put a brute force engine which has qualified that within 2 minutes it is going to send 5 wrong failures of an authentication. And then if the next 30 minutes the brute force will pass, that's a second transient I would write. That look for next 30 minutes, because most brute force engines, they die after 30 minutes. They will not attempt with the same. They will now look for enhancing and scaling up their brute force attack. So what will happen now? So I have now moved the event in my correlation embryonic state, that if the success happens within next 30 minutes, keep it in the transient state. Now imagine that yes, the brute force tool is really successful now within 30 minutes. What will happen? A transient event will get concluded into an end state. Because if a transient 2 means end, ensured, for sure I am sure that yes, this is a brute force attack. So that's my end state. So within 2 transients, starting from an embryonic state of any one failure, the transient 1 and 2 will lead to a final state of the correlation, and that's called as if this happens. Now if you just visualize, and all of you have done a Boolean equations, you will understand that this operation can very easily be written by Boolean statements. And very simple Boolean statements, and or operators. While in the Boolean equation, a very powerful operator is also used, the NOR gate and the XOR gates. So all those operators are there in their regular expressions. And with the more and more different language frameworks coming, with Python, etc., even it is extended beyond just the Boolean expressions. It's becoming a more complex expressions. And the very powerful correlation rules are written. Same way you can say, okay, if a firewall has seen some IP scan from a machine and now it has seen a successful connection on a HTTPS server, and then within a HTTPS server, somebody has started to do, in the IPS I am seeing now, a SSL overload attack or a SSL overload alert. So different tools are seeing different things, and somebody as an engine, a smart engine, will start correlating it by virtue of our regular expression. So that's one kind of correlation. Another kind of correlation which was very, very popular between 2000 and 2015, and it's still popular today, is the vulnerability based correlation engine, VCE. Now what it does is, it depends upon a third party to conduct a vulnerability assessment on an end machine called web server for both the operating system which the web server is having and the application which web server is having. So let's say it is hosted on Solaris and it's a Netscape web server, and a Solaris version 11.3 and Netscape version 9.4. Now what will happen? The vulnerability assessment tool will scan these two and will figure out what are the vulnerabilities which are currently known and existing on these two machines. And it will keep a record of that. That record for all the vulnerability scan can be saved as an XML file. Now this XML file, I will push it on the SIEM. Now what this XML file has? It has the evidence of my previously unpatched Solaris and Netscape machine, which was natively installed without any hotfix with version 11.4 of the Solaris and Netscape 9.4. So it was having 15 vulnerabilities, imagine, for example, just for hypothetical. So this XML file comes on the correlation engine of the SIEM. And now let's say we start seeing some attack from outside world on the same web server, which is hosted inside my bank with the same operating system and the web whom I have done a vulnerability assessment. So what will happen? You'll see that when the attack was coming and it was targeting any one of those vulnerabilities, what will happen now? If it is targeting a known vulnerability, immediately the SIEM will start giving an alert with a higher value of risk. Else, if the vulnerability is being targeted by the attack and that vulnerability does not exist on my machine in that list of 15 vulnerabilities that are being recorded in that XML file, it is not a problem for me. That means I might as well ignore it even if I'm seeing that event. So that's the level of correlation which was powerfully happening in the SIEM, both with the help of regular expressions and the vulnerability based correlations. Only thing which you have to remember in the vulnerability based correlation is that SIEM were dependent on third party vulnerability assessment tools. Now what has happened in the current times in 2020 when we are talking now, very few SIEMs have bundled a vulnerability scanner inside their own machine. So which means SIEM is self-sufficient. But majority of them still today are dependent on third-party vulnerability correlation, vulnerability-based assessment tools for delivering a vulnerability correlation engine capability. Regular expression has been into existence for last 2 decades. And regular expressions means tomorrow when a new ransomware will come, the industry will come to know by virtue of an advisory that yes, these are the starting points of an attack recognition. That means you detect this way, and then you will respond only once you are able to reach up to the final state. So you will get to know by advisory that what are those transient states attack takes. So you will write a new correlation rule based on the advisory published. So what does it mean? That regular expressions are always a post-attack situations. So they are the rules created once somebody has seen the similar attack pattern. But since they pick up the pattern, if they are rightly configured, they do a very right job and very fast. So this is what it means in the correlation. Once the correlation is done, if you see the normalize to aggregate, aggregate to correlate, these are all unidirectional steps, which means they move in the sequence. But presentation layer gives the output of a correlation tool to a dashboard, and also you can customize an existing correlation rule to become better fine-tuned, or you write new rules in the correlation. Therefore, you see that as a bidirectional. That means the presentation layer, which is interacting with the SOC operators, is actually a bidirectional component. This thing explains the SIM in a very, very quick, if I have to now, that was an explanation in detail. But if somebody asks me very quickly, okay, define what actually SIM does. So now this is what I will summarize. Centralize the logs from network, compute, apps, security devices. We have seen that. It will normalize the logs. It will aggregate and correlate the logs. And then what will do? It will generate the alerts for my operators. And it will help in forensics for my operators. So this is what all is there in the four form of explaining them what exactly a SIM actually can do. So SIM is the most common and the most core tool of the SOC, but it's not a SOC itself. What else a SIM does? That it is also a conglomerate where the local intelligence gets collected. So you guys can write down these three terms: indicator of attack, indicator of a pivot, and indicator of a compromise. So when I look at a SIM, any event might exist in any one of these three states. Okay. What is an indicator of an attack? Indicator of an attack is that authentication of a user has failed. That is a possibly an attack, but it is yet not established that it's an attack. Okay. So, but it's not a normal behavior, because I am expected to give the right authentication. Even if there are 5,000 people in the morning who will log in into Windows AD or any other LDAP, I am expecting that 4,000 users will log in the first attempt itself. The 1,000 users who might struggle, they may not struggle every day. So in nutshell, I might see that 100 people every day in the morning have a failure. 4,900 people will pass in the first attempt. So at least those 100 indicator of alerts should get recorded in the metadata of SIM, somewhere in the background data. Not necessarily that it has to be published on the front face, but somebody has to be aware. So such informational alerts, which can become which have a potency to evolve themselves into an attack, are called as IOAs in a terminology, indicator of an attack. Now let's look at the other scenario, other possibilities. We all know print servers, and in an organization of 100 users, 500 users, you will always have a centralized printing. In the centralized printing, you might have 2-3 printers published in some central space. Now, printers are supposed to print, but printers always have a temporary storage called as spooler, and they will have an IP address because they need to be reached from the network. And their job function says that they are always going to receive a data from an end compute. They are not going to, never going to send the data out. They're not supposed to send an out. But what if I see that my print spooler, so now let's imagine that we are recording logs from print spooler, and every day the SIM learned that a typical storage peak on a printer is 100 MB document. That's it, or a composition of multiple. So that's a learning understanding which it has built. But on one given day, some hacker compromised printer daemon or a printer service, and he started moving the important critical documents firstly in that spooler, because they know that that's a temporary storage, they can keep that records. And always understand that when a thief enters a house, he doesn't want to steal only one data and move out. He wants to collect some multiple items together and then move out. Yes, 1 in 100 thieves will definitely be the ones who are looking for only one thing, and they get that one thing in the right first attempt. So they will run out with the first thing. But in most occasions, it's a standard thief behavior that when they enter and ransack house, they will just try to figure out as many maximum things they can get in that limited time which they've got inside the house. So same are the behaviors of the hackers, that when they get into the house, they start stealing files very quickly, anything which comes, because they don't have a time to read that PDF and then decide whether it's to be stolen. So they just start collecting. And when they're collecting, either they have to store it locally on their hard disk. But if that happens, that means somebody will trigger very soon that why this activity is moving out. So they start storing in those temporary storage spaces like print servers. It's a very, very common format of attack. So if that happens, that means that print server is increasing its spooler size. And it is a place of pivot now, which means somebody has pivoted on that. Second example is that if a machine, which is a desktop, it starts sending too many connections to the peer hosts. Earlier it was not doing. Why it is doing now? Because a bot has come on that, and its commander is telling that try to find yourself kind of people on the net. So it's sending communications one after the other to infect others. So such things are called as pivots. So there are some events which will be recorded in the SIM as indicator of pivots. And the last stage is the indicator of compromise. So with the enrichment of understanding of indicator of attack and indicator of pivot, we can qualify either one of them or all of them very fast to indicator of compromise, which means the actual compromise / attack has happened. So for that reason, to move fast, to cover that journey, instead of an attack covering that journey from pivoted extended storage happening on the spooler to actually stealing those files and taking it out from a printer, if that happened, that means I am already now inside the breach. The breach has happened. So I will only do a forensics / investigation. I will not be able to stop that attack from happening. If we need to stop such attacks from happening, we need to enrich the IOAs and IOPs to become and qualify themselves to IOC, because in the IOC we'll have more confidence and we can block them. That's what is the whole objective. So these are the conglomerates of intelligence, which is local inside the infrastructure. In the processes now, so that completes the tool part, the SIM part, the primary tool or the most important tool. And we have understood that there is an additional tool which might be required, and that's for vulnerability correlation. So moving on to the processes, the second part, we all know that the service level objectives are defined like a level 1 engineer or the front phase engineer. He will do a 24/7 operation. He will handle a priority 1 tickets within 15 minutes, a priority 2 tickets within 0 to 45 minutes. So similar way, we define some process for my engineers. Also, we will define how an incident will be handled, like a security control, network control, devices will send a data to SIM. Now SIM will define a score. that score will get further enriched by some third party intelligence, and this will help me defining the risk score matrices. Now I am doing a triage. Triage is deciding that which probability or possibility of the symptoms will decide what action to be taken. So when there are choices to be made, then the flow charts have a process A, process B, or a process C to be triggered subsequent to the respective decision tree. So here the decision tree comes here is, if the risk is above 8, yes, go automate an action. And for automating an action, create an IOC and stop by writing a new rule in the firewall or in the URL filtering or giving a new signature to your antivirus that stop these things from happening. But what if the score is not greater than 8? Then what should I do? Is it less than or greater than 5? Yeah, it is greater than 5. Then man, give it immediately to your human beings, which are called as hunting team. Hunters are the ones who will hunt for more information. They will be enthusiastic, inquisitive to know more about that event, so that they understand that, and if they find and qualify by hunting more that yes, this is qualifying for a IOC, then go and apply that rule back. What if the score is not greater than 5? Create only a report. And what if the hunting team decides that no, it is not an attack? They don't need to generate an IOC. So what will happen? They will just be in a silent report that yes, something had happened in the past. So this is just like a one run book example. Okay, so we set up such tools for different kinds of attacks, like a phishing attack or a SQL injection attack or a core banking attack or a loan application attack. So we keep on writing such rules in our rule book so that people and the tools can work in collaboration with each other. Then in the SOC team, there are 3 kinds of people typically deployed. Alerts are received from SIEM platform, or the opposite might happen, that somebody is seeing a problem and all of a sudden SIM was not the one who triggered it, but the people are seeing the problems. They are saying my applications are running slow or my web server has automatically rebooted. So therefore a help desk or other IT teams might also initiate or trigger a security event. In such case for SOC, that tier 1 team is doing primarily monitoring 24/7. They are available. They are opening tickets. And when they realize that, yes, this was a false positive, they will understand that. But if the false positive is not there, but there is neither a clarity that, yes, this could be an incident, they continue to investigate and keep on trying to see if they can mitigate if the attack is going on. Else, if they are not able to solve it, they move the event or they tag the event. Actually, that's called as tagging, tag for tier 2. The moment they put it for level 2 engineer or a tier 2 engineer, the level 2 engineer is supposed to do a deep investigation. CSIR stands for Computer Security Incident Response Team, which means they are supposed to do a response function. They seem to be more experienced. They might have seen a similar issue earlier. And if when they are doing an attack analysis, there is a likelihood that they might be expected to do a triage. Triage is whether to put this patient into a ward or into a ICU or onto a ventilator. All that is called triage. Seeing the symptoms or seeing the behaviors or the unclarity also. Sometimes the patient may not be symptomatically or the event may not be symptomatically giving the enough information. So they need to be put up in the isolation and monitor this more aggressively. So all that are called as a triage functions. And triage is a term which has been taken into computer incident response from the medical terms only. And depending upon the triage, the mitigation / recommended changes are other standard operating procedures or the runbooks which are available inside those frameworks of response of processes. Then the tier 3 are more advanced people. There may be having a reverse malware capabilities, and they might also be the people who are contributing to the world in the form of IOCs, because a typical L3 engineer might be 7 to 10 years in the cybersecurity space. Okay, So they are part of the containment strategy and execution once the epidemic kind of situation happens. So all this is what is the different level of people who are there. In the summary, the SOC is supposed to deliver an operator's interface. So this is composition of entire SOC. Okay. So operators should have a dashboard where they are seeing in the real time. They are also able to alert. They are able to chat and send mails for the workflow purposes. And also they should be in a position to customize their own dashboards. So that's like for operations, these guys will do it. In the event monitoring, what is important? The correlation rules have to be defined. Sometimes automatically they have to be embedded from the vendors. So all the correlation tool engine vendors, they are sending those automatically to be triggered correlation rules. Plus they will also allow you to customize rules. Then data normalization and data reduction by aggregation, all these needs to be part of the monitoring function. If you don't do that, your monitoring will be not that great. And the graph and the graphical or the visuals are most important for monitoring. We all know that when we see a red color, blue color, timers, etc., the bar charts, the pie charts, we are more attentive and more action oriented than just seeing a text-based data. So all that is part of the ensuring that yes, you are doing all that functions in the work monitors. Then workflows have to happen. There have to be a absolutely process driven level 1, level 2, level 3 engineers. When are they going to intervene? When are they going to escalate it to the next level? When are they going to shift the changes from one handover to another? So there are proper handovers and so on and so forth. So all that is what exactly defines the workflows. And last but not the least, there have to be weekly, monthly and daily reports which are discussed to understand that how many false positives were reported and how you are reducing them, how you are fine-tuning your correlation tools. Why doing all this? You also have some third-party tools with whom you can share your SIM's data over the CSV, and they will give you a better understanding of how the operations went through. So all these becomes a SOC deliverables of that team. And they all deliverables cannot be delivered until and unless we have a strong integration between 3 pillars, and that is people, processes, and tools. So this brings us to the end of the session 1. We'll start the session number 2 at 4 p.m. today. And you can keep on visiting. You can utilize this half an hour for writing your notes, for doing further Google, so that when we come back, we will be starting with each one of those security operations centers generations which we have seen in last 2 decades. So that's the next session, which is the part 2 of this series on security operations centers to cyber fusion journey. And I'll welcome back you again after half an hour. Thank you very much.